The series n equals 1 to infinity, 3x minus 2 all raised to the n divided by the quantity n times 4 raised to the n. This center for this one is a little bit more complicated because it isn't just x minus c, it's 3x minus c, or 3x minus 2. So we're going to come back and revisit the center after we apply the ratio test here. So let's start with that. So L equals the limit as n goes to infinity of the absolute value. We have the n plus 1 term, so 3x minus 2 all raised to the n plus 1. We have an n plus 1 in the denominator and a 4 to the n plus 1. And then we're going to divide by the n term. So I have 3x minus 2 raised to the n. I have an n and I have a 4 to the n. Then we'll start simplifying here. So I can take care of that nth term on the 3x minus 2. So I'm left with the absolute value of 3x minus 2 that can come out in front of the limit. And this 4 to the n and the 4 to the n plus 1 just leave me with a 4 to the first. And that 4 is in the denominator. It can also come out in front. And the absolute value of 4 is 4, so I don't need the absolute value on the 4. I do need it here on the 3x minus 2 because the x is a variable that can take on any value, positive or negative. So that's why I still need it here with the x. And then I have the limit as n goes to infinity of n over n plus 1. So my leading terms are n over n, so this limit is just going to 1. So that gives me the absolute value of 3x minus 2 over 4. And I'm going to set that to be less than 1. Okay, and so I can multiply this 4 over, and then I'm going to expand out of this absolute value. So what I really have is negative 4 is less than 3x minus 2 is less than 4. And I'll add 2 to all three sides here. So I have negative 2 less than 3x less than 6. Then I'll divide by 3. So I get negative 2/3 less than x less than 2. Okay. So here we can actually find this total distance here. So this total distance will be 2 2/3. And if I cut that in half, that's going to make my radius equal to 4/3. Okay. And if I start at one endpoint, so if I start at this right endpoint, I can subtract 4/3 off. I'll find that my center is actually at x is equal to 2/3. So we have our center and radius, and now we're ready to test our two endpoints. So I'm going to start with my left endpoint, x is equal to negative 2/3. So the series n equals 1 to infinity of 3 times the negative 2/3 minus 2 to the n all over n times 4 to the n. So those 3's cancel out, and I have negative 2 minus 2. So that gives me a negative 4. I have a negative 4 to the n over n times 4 to the n. Okay. So this 4 to the n and the 4 to the n are going to cancel. I'm left with a negative 1 to the n over an n. So we get n equals 1 to infinity of negative 1 to the n over n. And hopefully you recognize that as the alternating harmonic series. So we can just write that that is the convergent AHS for alternating harmonic series. And that means we are going to include this endpoint of negative 2/3. And then we have the right endpoint left to check. So x is equal to 2. So I have the series n equals 1 to infinity. I have 3 times 2 minus 2 to the n all over n times 4 to the n. So 3 times 2 gives me 6 minus 2 gives me 4. So I have n equals 1 to infinity. I have a 4 to the n over n, 4 to the n. So that gives me 1 over n, which is the harmonic series. And we know the harmonic series diverges. Okay, so I would not include the x equals 2 endpoint. Okay, and so we're down to our last step, which is just to write our interval. Okay, so that step is to kind of combine these first two. So we will use that negative 2/3. I'll use a square bracket on it. And I'll put a comma. And then my other endpoint is the 2, and we're not including the 2. So it gets a round parentheses on it. And there you go. That's how we do that one.